Hello everyone. So in our previous lecture we have seen AVL to insertion with single rotation, that is RR rotation and LL rotation, right? We have two videos. So in that two videos we have seen RR and LL rotation. Now in this video we are going to see the double rotation, right? So RL and LR rotation. So when we need to apply this double rotation and when we need to apply the single rotation, right? That's the question many of you might be having. So as we already seen in previous lectures, right, previous videos, that when the new node is added, I'll just quickly revise it, that when the new node is added to the left of critical node, so that would be L rotation, and the critical node would be rotated towards the right. And in RR rotation, when the new node is added, because like we need to after insertion, right, after insertion we need to check the balance factor, and at that moment we came to know, yeah, this is my critical node, and then we need to again recheck that the newly added node is added on which side of my critical node, right? So if it is on the left side, left of left, right, if it is left of left, then we apply LL rotation. If it is right of right, then we apply RR rotation, right? And as I told you earlier, that in LL rotation we need to rotate the critical node towards the right, and in RR rotation we need to rotate the critical node towards the left. It's the opposite, right? Now in this video we are going to see about LR rotation. So when the critical node is there, so the newly added node, if that node is on the left of the right, previously it was the same side, left of left or right of right, but when it is on the reverse side, like left of right or right of left, then we can say that it's a we require double rotation, right? Either LR rotation or RL rotation, right? You might get confused, right? So let me explain you this with example. So let us say that I'm having this 45, right? I'm having this 36 over here, and I'm having 39 over here and 27 over here, okay, and I'm having 63 here, right? Now if I check the balance factor, so balance factor for 63 it's a 0, for 39 it's a 0, for 27 it's a 0. If I check the balance factor for 36, again it's a 0. If I check balance factor for 45, so it's a 2 minus 1, that's a 1, right? So as of now it is balanced, right? So we can say that it's my AVL tree, right? But if I add one more node, right, let us say 37, right? So we need to add 37. So 37 would be added at this position because it is lesser than 45, greater than 36, and lesser than 39. So 37 would be here, right? Now again we need to check the balance factor, right? So like let me quickly update the balance factor, right? So as you can see here, that for the balance factor for 37 is a 0, right? The balance factor for 39 is 1 minus 0, that's a 1. The balance factor for 27 remains same, 0. The balance factor for 63 remains same, that's a 0. The balance factor for 36 is 1 minus 2, so that's a minus 1, right? Now if I check the balance factor for 45, so we need to have the height, that is the longest path, right? So it's a 3 minus 1, so that's a 2. right? Now here this is like my critical node. So as you can see, this is 2, right? So I am having a critical node, that's a 45, right? 45 is my critical node, right? Now I need to check that the newly added node is added on which side, right? So if I check, so it's like this, first is left, then it's right. So this is left and this is right, right? So this my newly added node is added to left of right, right? So this is my LR rotation, right? We required LR rotation over here. Now how to do LR rotation, that I'll explain you, right? So in LR rotation, in single rotation, what we do, we rotate the critical node itself, right? Now in a double rotation, we require 2 rotations. So in the first rotation, we rotate the node after the critical node. So this is like this 45 is my critical node. So after that, what node I am having, that's a 36, right? So the node after the critical node, I'll rotate it towards left, right? But not the critical node after critical node, right? So I'll rotate it towards the left because this is my LR rotation. So first rotation should be left, right? So that would result in something like this, that 45 would be here, 63 remain as it is, right? If I rotate it towards left, so I'm having 39 over here, 36 is rotated, so it would be here, and 27 here. So after this 27, this 37 is still remaining, right? So 37 was previously the left child of 39, right? But when I rotate it, right, when I rotate 36, right, so 36 will become the left child of 39. It's like a chain, right? If I pull this up chain, so this will automatically comes down, right? So 36 will become left child of 36. So you might think that what about 37? Because previously 37 was the left child of 36. We cannot make it right child, right? If you think that, oh, that's fine, I can simply make it a right child of 39. No, you cannot make it right child of 39 because as per the binary search tree condition, the right child of 39 should be its value should be greater than 39, right? So here what we need to do, we need to make 37 as a right child, but not of 39 but of 36. So my 37 will be here. So always keep in mind that after rotation, suppose you have rotated any node, right, and after rotation it might be possible that previously you were having some left child of one parent, that A is a parent, so B is a left child of parent. But after rotation, it might be possible that C becomes the left child of A. So what about B? In that scenario, you need to make B as a right child, but not of A, but of C, right? So I hope you understood this, right? So now this is like first rotation is done, right? First rotation is done. Now we need to go towards the second rotation. So second rotation, as you know, it's L and R. So second rotation that we need to rotate towards right. Now whom to rotate? So that you need to rotate the critical node. Previously you were rotating the node after critical node, but here you are rotating the critical node itself, right? So you have this critical node 45, so you are rotating this 45 towards the right. So if I rotate it, this 39 will become my root node, right? And this 45 will become the right child of that. 63 will remain as it is. 36 will be here. 37 and 27 will be here, right? So this is my answer after the LR rotation. So we need to just check the balance factor again, right? So if I check the balance factor, so balance factor of 27, it's a 0. For 37, it's a 0. For 63, it's a 0. For 45, it's 0 minus 1 minus 1. For 36, it's a 0. For 39, it's a 2 minus 2. That's a 0. Now, as you can see, that balance factor is managed, right? So here, it's a balance AVL tree. Now, you can say, yes, this is my AVL tree, right? So, this is about LR rotation, right? So I hope you understood this LR rotation, right? Now we are going to see the RL rotation, right? RL rotation will be same as the LR rotation. The only thing is that first you need to rotate it towards right, and then you need to rotate towards left, right? So we'll do one thing, we'll discuss this in next video, so you will get some idea, because at a time if you learn many things you might get confused, right? So in the next video we'll learn about RL rotation, right? And in this video we learned about LR rotation. So I hope you understood it. Thank you for watching this video, and in the next video we'll see RL rotation. Thank you very much.